3.1 is on vector-valued functions. A vector-valued function is just a function like this that gives you a vector as its output. And the vector could be written as a tuple, or it could be written as a function times I plus a function times j. And you might also have a function times k if it's in R3 instead of R2. So here's a first example. We've got r of t is equal to cosine t times I plus 2 sine t times j. Now, if we wanted to plot this, we'll have t, and then we'll look at cosine t. That'll give us our x, and 2 sine t will give us our y. So at 0, cosine of 0 is 1, sine of 0 is 0. At pi over 4, cosine pi over 4 is root 2 over 2. And this sine is root 2 over 2, so this is just root 2. Then at pi over 2, cosine of pi over 2 is 0. Sine of pi over 2 is 1, so this is 2. So we can use symmetry here to graph this. One, two, 1, 2. So starting here at 0 and going up to pi over 2 and then pi. Let's see, we start out at the point 1, 0. So that's here. And then root 2 over 2, that's like 0.7, and root 2 is like 1.4, and then 0, 2. So we get this. And if we plot the rest of this, it would look like this. And so our graph here is it's an ellipse, and it's moving in that direction there. So that's one example. I want to look at two more examples. This is the example r of t is, let's see, sine t, cosine t. If we make a chart like this, or for this one, if we look at 0, pi over 4, and pi over 2, see, sine of 0 is 0, then root 2 over 2, then 1. Cosine of 0 is 1, then root 2 over 2, and then 0. So if we draw this, this gives us a circle. But notice at time t equals 0, we start off at the point 0, 1. So we start off up here. Then at time pi over 4, we're at root 2 over 2 for x and y, and then we're at 1, 0. So this gives us a circle. It goes around like that, and this is the direction. All right, I want to look at one more. Both of those that we've looked at were in the plane. Let's look at an example of a vector-valued function in space. This is a neat function, I think. R of t is cosine t, sine t, and then t over 2. So if you think about what this is, if we didn't have this last part here, this would just be a circle. I want to look at this when t goes from, say, 0 to, I don't know, several rounds, let's say to 8 pi. So if this weren't here, it'd be a circle. But now it's a circle, but it's rising. The z coordinate is increasing as t increases. So what we get here, this gives us a spiral or a helix. And you can graph this nicely on Desmos, but I'm going to draw a quick version of it. It's going to be a circle, a spiral. It looks like this, like a spring. So that's a vector-valued function in space. All right, and that's it for this section.